Hi. So I just started sharing my screen there. I'm gonna give the presentation in English, but if you want to ask me a question afterward in French or whatever, I can answer in either languages. Um, so yeah, this is my presentation, table retrieval in dialogue. And the collaborators along with Siva Reddy are Harm Devery and Statistics Canada. So I'll just go over the agenda today. So we're gonna start by talking about what Statistics Canada is about and why we're interested in collaborating with them. Afterward, we're gonna talk about the motivation of the project, and then we're gonna define specifically the task that we're focused on at the moment. And then afterward, how do we approach this task, like what methods we use, as well as what the goal of the project is once we are done with the method, and then what are the next steps, whether either within the same project or in a future project. So this is still to be determined. So first of all, about Statistics Canada. So you can find like the website by going to statcan.gc.ca. And that's their homepage. So you can see that on the right side. So people like go to this site to find data sets or tables for either like for a course or with their own research, or even in the context of their own work at a company, for example. If, however, they're unable to find that information, then they would use the chat option that you would see on the bottom right, but you don't see it here. And they would be connected to a human operator who will be asking them for more details. We're going to communicate with them and finally suggest them useful tables and useful ways to filter those tables. So we're going to just take a look at a simple conversation. So if you look at the left side first, you would see that the guest will join the chat and they will be asking a question about, for example, the income data of before 2015. The operator will answer them, say, hey, how can I help you? And then as the guest gives more details, the operator will ask more questions. If they're still unsure, they can retrieve the table. And then finally, when the operator has enough information, they will go to the StatsCan website themselves, look for a useful table, and then return it as a link. So I truncated it here, but the table that they returned for this conversation, and this is a real conversation, by the way, it's the table on the right side, and that's exactly what the end user was looking for. So for our project, we wanted to tackle a few problems that could, if resolved, that could help the operators. So first of all, how can we help them find the tables faster, right? So maybe they were going to take a few minutes to even find a relevant table because of the intrinsic and more like details query by the operators. And then for example, often like people will ask similar questions and the operators will take a lot of time to like keep typing out the same thing. So can we like kind of make those repetitive questions, those repetitive comments answered faster by the operator, like for example, by generating a prompt response. And then can we decrease the wait time when the operators are busy, for example, by using a conversational agent that can answer the basic questions so that the operators will only talk to people who have actual complex questions. So based on those motivation, we defined our first task, and we're going to mention about the other tasks later, which is to use machine learning to suggest a relevant data set for the guest that are visiting StatsCan. So the guest would write a question. They would type a question, and the operator would keep chatting with them, asking them for more details. And then as the conversation goes on, the machine learning model that would solve the task would look at the conversation that's ongoing and propose a useful table that you see on the bottom right. So here, like on the bottom right, you see three kind of tables being proposed. And the information we give is the title of the table, the different like tabs of filters that we have there, and when it was released, as well as the as for example, whether it's about geography, whether it's about a certain community, for example. So that would save time on the operator, because if they find a relevant table directly from our machine learning model, then they won't need to have to search it by themselves, and that would save a few minutes every time, and that adds up pretty quickly. In terms of method, we are proposing a baseline models that again uses machine learning. So we are planning to use a neural network based model that will learn to correctly retrieve the correct table. The specific model that we're using is called dense passage retrieval. So that's really just the technical name for the neural network we're using. And it reads the text and it tries to compare it with other similar table titles. And then we compare that dense passage retrieval network with a baseline model, which is the BM25. So that's just the traditional retrieval method that doesn't learn anything. It just matches the words in the title with the words in the conversation, and then try to make a guess. And then we experiment with more or less information. So maybe just the table title is enough to find a relevant table for the end user. But maybe they need more information. Maybe a column is the name of each column, and there could be like 10 different columns, for example, might be useful. So that's a lot to experiment with. And then the goal, once we have released those the two baselines mentioned in the previous slide and define useful task, the goal is to release open challenge for the researchers and developers to join. So on the right side, I have an example of a challenge that my supervisor have released in the past. That's called conversational question answering challenge. So there you can see there's a little kind of leaderboard that shows you like all of the top models that were submitted by other researchers. And the baseline model is actually like really at the bottom. You don't see it even. That's because people are really encouraged to publish and to submit to the challenge. And that in turn result in better models that that organizations can use. So for example, in our case, StatsCan might be able to use the best model on the leaderboard directly for their agents to find relevant tables. So the data that we're going to release has about 4,000 conversations between the guests and the operators, as well as over 5,000 tables. That's like and all the tables are available on StatsCan right now. And there's a subset of those tables that we're going to provide as only the metadata, and the rest is going to be the full table. So we're going to give about 1,000 full tables. And the reason we're only given a subset of the 5,000 is because some tables are very, very large. So just 1,000 table is already about 15 gigabytes of compressed data. So that's it for the goal. And for the next step of the project is to look into automatic response completion. So we don't just provide a link to a relevant table. The model will also provide a prompt response for the guest. So this way, operator can just copy paste the response, maybe modify it a little bit, and send it. And that's going to save them a little bit more time as well. And then the next step with when you take those two models, the retrieval model and the automatic response generation model, and you put them together, then you might be able to create a conversational agent that would not need the supervision of the operator, and they would be able to answer those queries without their help. And that's going to save time when operators are busy, for example, or when it's outside of business hours. So that's it for for the presentation. So I think it was just right on time. So is it time for questions?